find the equation of the line connecting the points -3 and 4, 5 and 8. So I name them x1, y1, first point to be -3 and 4, x2, y2 to be 5 and 8. Equation of line passing through this point is y minus y1 times x2 minus x1 other side, x minus x1 times y2 minus y1. Now y minus, what is y1? y1 is 4 times x2 minus x1, we have 5 minus -3, which is +3, x minus x1, x minus -3, which is x plus 3, and y2 minus y1, 8 minus 4. Now if I simplify, we are going to have 8 times y minus 4 times 8. Other side, we have 4x, 8 minus 4, 4. 4 multiplied by x plus 3 is 4x plus 12. And if we simplify, it's going to be y equal 1/2 x. I have 12 and this 32 moves to the other side, becomes plus 32, 44 divided by this 8, which is 11 half. Now this is the equation of the line, which shows the slope. Here slope of the line is when we have y equal mx plus b, then this is the slope. Slope is 1/2. And about the y-intercept and x-intercept, also we can give the value 0 for x to y-intercept. So if I want to find x-intercept, then we need to give 0 for y and find the x value. If y is 0, then x becomes -11. And for y-intercept, if I give 0 for x, then I can get 11/2 for y-intercept. Now I can connect these points on x and y-axis and show the graph of the line. Graph the following rational function. Here we can see that it seems that we have the function 1 over x. We know what's the graph of y equal 1 over x. If I want to graph this, it's going to be a hyperbola with 2 branches like this. When x is 1, y is 1, x minus 1, y minus 1, and when x approaches infinity, the graph approaches 0. And when x approaches 0 from right hand side, our graph goes positive infinity, from left hand side, negative infinity. So we know this one, which is the graph of 1 over x. But here we see a negative sign, then I need to know what's the graph of minus 1 over x. So if I multiply any value on this graph to negative sign, it's going to be reflected across x-axis, then this part of the graph will be reflected down. Any positive value will change to negative, and these negative values of y will change to positive. So this one is minus 1 over x. But we can see that instead of x, I have x plus 4. So if instead of x, I have x plus 4, it shows that we have 4 units shift to the left. So 4 units shift to the left, and this plus 2 means 2 units up. Now, we can graph these horizontal and vertical lines, x equal -4 and y equal 2. So here we have y equal 2 for 2 units shift to up. It means that the graph which was close to y equals 0, now it's going to be close to y equal 2. And the other one, which was close to y-axis, so x equals 0, now it's going to be close to x equal -4. Or we can see that when x plus 4 is 0, it means that x is -4 or x minus 4 is the vertical asymptote. So we have vertical asymptote here, x equal -4 and horizontal asymptote y equal 2. Now we need to graph similar to this. Instead of x and y coordinate system like this in between this second and fourth quadrant. Now we are going to graph similarly in this blue coordinate system. Now this part is going to appear here, but the other one is going to intersect x and y axis. This one also here. Now these points are important. We need to introduce the x-intercept and y-intercept. We can see that in our graph, if x is 0, then y becomes 2 minus 1/4, or a little bit below 2. So this is x-intercept, or 7/4. So x-intercept, so y-intercept is when the graph intersects y-axis. Y-intercept is 0 and 7/4. And for x-intercept, what happens if y is 0? Y0 gives us 1 over x plus 4 equal 2, or x plus 4 is 1/2. And this one says x is -4 plus half, somewhere here a little bit to the right of -4, or -7/2. Now y-intercept is 0 and 7/4. X-intercept, or the intersection of our graph with x-axis, is -7/2 and 0. Find the limit of this function when x approaches -3. If x approaches -3, we can see that we are going to have indeterminate form 0 over 0, substituting -3 for x. Then we need to find the 0 factor and cancel it out. When x approaches to a, x minus a is the 0 factor. X minus -3 is x plus 3. So we have this factor here and also here that makes numerator and denominator 0. Now in numerator we have another factor. Since we know that it has this factor, then to have this x squared, I need another x here, and to have this 12, we need another 4 here. 4 times 3, 12. And other quadratic equation, quadratic term the same. To have x squared, we need this x. To this -15, we have another -5 times 3, -15x approaches -3. Now we can cancel this factor, because when x approaches -3, it is not -3 itself, or this parentheses are not a 0, we can cancel. Then we have x plus 4 divided by x minus 5 when x approaches -3. Now we can substitute and get -3 plus 4, -3 minus 5, or 1/8 with negative sign. This limit x approaches infinity. We say that when x approaches infinity, the dominating term is the highest power. It means that I can just keep this -5x squared from numerator And in denominator, dominating term is x squared. Before finding the limit, we can cancel these factors. Now we have minus 5 over 1. When x approaches infinity, there's minus 5. This function x approaches 6 from negative side. This time it is not 0 over 0, it's not indeterminate form, but denominator becomes 0. Then we need to know whether it is very close to 0, but positive or negative. X approaches to 6 from negative side means x is less than 6. If you move 6 to the left, we have x minus 6 less than 0, or this one is negative. Now here we have in numerator, we have, if I substitute this 6 here, 6 plus 2 is 8. And in denominator, we have a number very close to 0, but not 0 itself, and it is always negative. 1 over 0 and limit is infinity, but this time it is minus infinity because numerator is positive, denominator negative. So in this exercise, we want to find the value for the parameter a to make this function continuous at all x. So we can see that when x is less than 3, so this function is linear function, continuous everywhere, greater than 3 the same, only 3 is important here. The function is defined at 3, so that one also makes no problem with the continuity. We need only to have left-hand limit equal to right-hand limit. So left-hand limit means the limit of our function when x approaches this point from left-hand side. Left-hand side means less than 3. So we can see that less than 3 is here. We need to use ax plus 1, x approaches 3. And this is 3a plus 1. Right-hand limit, similarly, x approaches 3 right-hand side. X is greater than 3, then we need to use second expression, and we have 3x squared. X approaches 3 from positive side. And we have 27. Left-hand limit equal right-hand limit gives us the equation, which is 3a plus 1 equal 27, or 3a is 26. And it gives us the value of a. So a is 26 over 3. So only for this value of parameter a, the function is continuous. A business manager determines that the total cost of producing X units, so we should know that this is for X units. If we produce 10 units, then we are going to have 10 times 9.25 plus a fixed cost, which is $150,000. So for a particular commodity, can be modeled by this function. So this is the cost function. If you want to find the average cost, so average cost, this is for X units, an average for each product. If we produce X units for each product, we are going to have this AX as average cost. So if I want to introduce average cost as a function, so it is C of X divided by X. C of X is defined by this 9.25x plus 150,000 divided by x. Since x is not going to be 0, then I can rewrite this and write 9.25 plus 150,000 divided by x. If we want to check what's going to happen in the long run, or we need to find the limit of this function or this average when x approaches infinity. If we want to produce so many units of this commodity, then we will see that this 150,000 is going to be very small or negligible value in comparison to the x times 9.25. And it shows that the cost for each unit is going to be only this 9.25. So if I want to find this limit, it's going to be the limit of 9.25 plus divided by x. When x approaches infinity, we know that this 150,000 divided by x, when x approaches infinity, this part approaches 0 and this 9.25 remains. And it shows that if we produce so many units of this commodity in comparison to this 150,000, very large number, then this part is going to be very small and small, or the average cost per unit is going to be just 9.25. So this is going to be the average